Welcome to the Advanced Manufacturing Summit. I'm Srinath. I lead go-to-market strategy and marketing for the design and manufacturing business at Autodesk. I'm here at the Autodesk's Technology Center in San Francisco. I'm very pleased to be here at the Advanced Manufacturing Summit. This is a great time to be in the manufacturing industry. A lot of changes happening in the way of how manufacturing technologies are coming together, how industries are coming together. And what I see here today is a group of people who are completely immersed in the world of manufacturing, coming here to exchange ideas and exchange information about how they look to the advanced technologies that will help them become more and more competitive in the manufacturing industry. This is the first time for Autodesk. This is the first virtual event, but more importantly, it's a first for the way we are bringing together the different disciplines of manufacturing in one venue. It's not a session dedicated to subtractive or to additive or to injection molding or to hybrid manufacturing. It's a session that addresses all aspects of manufacturing in one venue. This is the one time where all the experts who are devoted to different fields of manufacturing can exchange ideas and can exchange information about what is the change that will propel the manufacturing industry forward as a holistic approach. The theme of the conference is manufacturing through change. And this is a particularly relevant topic for today's times. What we have seen in the last 2 months is digital transformation that usually would have taken 2 years compressed into a very, very short duration. And this is not just me saying it, this is analysis from Microsoft. What they're seeing across all industries is that the pace of change has compressed in the last couple of months because of necessity, because of the pandemic. What's really exciting for me is this gathering of experts with enormous amounts of experience. This is an opportunity for all the expertise to cut across industries and cut across disciplines. This is a time where each one of you have an opportunity to help each other in the face of this enormous amount of change. In the next couple of days, you're going to hear from many experts on how they're using this opportunity to transform their companies. You'll also hear from Autodesk experts on what they can do to help you thrive in the face of this change, how they can help you compete more effectively in the face of this change. This is an amazing opportunity for you to learn about the latest and greatest technologies that are from Autodesk. One of the things that we hear from customers about what's getting in the way of their digital transformation is absence of consistent experiences as they go from different disciplines such as CAD, CAM, or CAE, and also just the way in which they collaborate amongst teams, amongst departments, across the company, and across their ecosystem. What we have built with Fusion 360 is a simple way for different disciplines and different teams to come together in one product development and manufacturing environment. It is a product that is built on the basis of helping people make things. We are very convinced that the product development and manufacturing of tomorrow is not about just painting pixels on the screen. It's about enabling customers such as yourself make products that compete more effectively in the market and are able to drive more profits for you. Fusion 360 enables simple, in the context collaboration by giving people access to information anytime, anywhere. This is fundamentally what teams expect, irrespective of where they're working. This is especially relevant now as teams are having to cope with remote work. The teams that were co-located in one location before are now distributed across the entire planet. And this is where Fusion 360 can play a big role in helping teams come together in a virtual collaborative environment. Not only does Fusion 360 provide access to the latest manufacturing technology ranging from subtractive, additive, and hybrid manufacturing, Fusion 360 also includes the next generation technology powered by artificial intelligence and machine learning. This is generative design. Generative design is not a design technology or a manufacturing technology. It is the combination of both, which allows designers and manufacturers to define problem statements, and their objectives, and this algorithm, which is manufacturing aware, then provides the designers and manufacturers a range of options that they can consider in order to be successful in their problem domain. This is how next generation manufacturing will be done. Fusion 360 gives you access to the new manufacturing extensions. Manufacturing extension gives you access to specialist technology on demand just when you need it. I'm excited to announce today that we're bringing new value to our power solutions. Starting in September, PowerMill, PowerShape, and PowerInspect will be offered with Fusion 360. What this change means for you is very simple. You'll be able to use PowerMill, PowerShape, and PowerInspect just like you use them today. In addition, you'll be able to amplify your design and manufacturing workflows using Fusion 360. Not only that, we're giving you access to all the features in the Ultimate tier at a more affordable price point. I'm thrilled that Autodesk is able to deliver this amazing value to you, especially at this time as you're worried about your cash flows. I'm particularly excited about what you will be able to do with this technology to build really great products. If you're curious about how PowerMill and Fusion 360 can work together, be sure to check out Rob Walker's session on day 3. In addition to Rob's class, the Autodesk team will be running many great sessions at the summit. But the sessions I personally enjoy the most are the presentations given by our customers. I love to hear your stories. The next story you're going to hear from one of our amazing customers, the Briggs Automotive Company in Liverpool, England, is the one that really showcases the idea of convergence that I was talking about earlier. Their work brings together functional and aesthetic design considerations with advanced material science and multiple manufacturing methods, which all contribute to a grand vision that can be best described as an ultra-high performance work of art. The new BAC Mono. But I've said enough. Let's hear from Neil Briggs.
My name's Neil Briggs. I'm co-founder and director of product development here at BAC. The business was founded in 2009. Since then, we've delivered cars to over 41 territories around the globe. We've been on an incredible journey with our partners, suppliers, and of course our customers. So the initial idea for the car started way back in the mid-90s when Ian and I started our own automotive design consultancy business, predominantly based in Germany. The vehicle architecture almost identified itself. It's inspired by a formula style layout, whether that be IndyCar, whether that be Formula 1, Formula 2, Formula 3. It's clear that the driver sits in the middle. The engine is mounted longitudinally along the center line of the vehicle, directly behind the driver, as is the drive line and the gearbox, which is then mounted further behind it. So the hard points of the car actually started to pretty much define themselves fairly easily from day one. There's a clear line as to what we focus on, and that is all about improving performance, and therefore we have this obsession, some might say, with weight save. So for us, we focus on clever use of materials. We focus on our processes and our clever use of the available softwares that we have to us in order to optimize the components on the car. A classic example of some of the innovation we've got here at BAC is our two-piece carbon hybrid wheel. So we've taken an alloy wheel, the lightest 17-inch alloy wheel in the world. We've made it 2 kilograms lighter. But we weren't content with that. We wanted to move that forward. And that's where we utilize generative design, work very closely with our friends and colleagues at Autodesk to basically apply the same load case to the same wheel to see where we can optimize the structure. And using the constraint system within the software, it meant that we could constrain the areas of the wheel that the designers were particularly protective about, and that then forced the software to look into specific areas to optimize the weight reduction. And I think the solution that we've come up with is absolutely incredible. We've saved an incredible 1.25 kilo just from the centerpiece alone. So we've moved this lightest wheel already further into just a completely different stratosphere. It shows a real nice development from the original wheel, which was designed in 2014, to our new wheel in 2020. And I'm going to take you up close and personal and show you the details around that wheel shortly. So there's lots of disruptive innovation and technology that's on the new Mono. Mono R, and that's been carried across onto the new Mono, was the first car in our history to utilise 3D printed parts, and with clever use of some of the new carbon filled materials now. For the first time in our history, we've actually become a supplier to the main manufacturing centre, which is where we're sat now, for components. We can try them on the car, we can test them on the car, and now as I sit here today, we've got actually over 44 3D printed parts on the car. So BAC was the first company in the world, and specifically in the automotive sector, to utilise graphene enhanced composite body panels. What that does on a molecular level is the graphene essentially enhances the structural properties of the carbon fibre. It means that we can actually take the number of layers of carbon fibre out, the lamination, out of the part, and therefore reducing weight. We're already attracting interest from other premium luxury automotive manufacturers who are interested in our journey with graphene. They understand the volumes that we're making at 30, 40 cars a year. Yes, that will be applicable in 1 or 2 years' time for perhaps the next McLaren Senna, or for perhaps the next limited edition version of a Porsche, for example, or an AMG Mercedes. So the new Mono represents the next stage of our design DNA, described by Jeremy Clarkson as one of the most iconic shapes he's ever seen. The car never ceases to amaze me or anyone else who sees it, just how striking it is. And to move that design forward actually was a really tough challenge. The car has got this slightly more aggressive, lower, sleeker, longer stance, which is even more striking and looks incredible. So I'm going to go ahead now and give you an overview of the new Mono, and specifically some of the new aesthetic or brand DNA which we've moved forward with this car as part of the evolution of the design. And we're going to start basically on the front of the car. So the brief predominantly was because the engine produces more power, therefore it rejects more heat, and therefore the radiators are bigger. So you'll notice that the lower to upper body ratio has changed. It's given the car more of a larger feel in this area, more volume. So there's therefore a need to get more airflow to the radiators. So therefore we've looked to clean up the front end and reduce the frontal area. So you'll notice that the lighting area specifically has gone from 4 lights in this area down to 2. So we've combined the indicator with the dip main beam. And then the main beam is now positioned in the front of the car. So what that's done is it's reduced the restrictions for the airflow essentially through the car, so we can feed those radiators with more air. But what it's also done is it's also formed in the center section almost like an aerofoil profile in plan view. So that helps us to sculpt the air from the front of the car, try and maintain attached air around the chassis section, into the side pods, around the side pods, and then maintain that attached airflow along the length of the car, and ultimately reduce the drag out the back of the car. The rear end has been completely restyled, so the rear wing profile has changed. It's a fixed rear wing, which works well and in harmony with the diffuser. The diffuser angle is unchanged from the original car, but the chord length and the profile of the rear wing has changed significantly to sleeken that off, which gives the car ultimately supercar credible top speeds of over 170 miles an hour. But I think the real headline with this car is how quickly it will accelerate. So 0 to 60, 2.7 seconds, so it's the fastest rear-wheel drive accelerating car in the world. We haven't quite got the four-wheel drive EVs licked just yet. and then 0 to 100 in under 6 seconds. So it's really a shattering performance, but very, very accessible and very, very rounded for the driver. A few more key things about the aesthetic. You'll notice that for the first time now, we have body panels which allow us to access the engine for servicing. So it's no longer a one-piece body, it's several pieces that have been manufactured together. Again, at the front end, you'll see there's been a declutter. We now have an electronic front hatch system, which means we no longer need the latch. So there's a lovely, nice, smooth surface there, which really forms part of the new aesthetic. And then a thinness to all of the design. You'll see the surfaces now have this real efficiency, and kind of liken that to nature, where you've got or an athlete, where you can see the skin stretched over these super taut muscles. It gives it a real purposeful feel to what the car is all about, which is ultimately its DNA. I think one of the most noticeable aspects of the car as well are the new wheels, which I'm going to tell you a little bit more about in detail. And to allow me to tell that story, I'm just going to take some of these 3D printed parts that I've got here, but also I'm going to basically focus in, and we'll do this around the front wheel, and this is around the carbon hybrid wheel, which essentially is a two-piece wheel. So this is the center section, and you'll notice that the outer section is made from carbon fiber. So for those of us who are familiar with moments of inertia and calculations, you'll know that it's most important and influential to save weight at the outermost point on the rim. It's to the power 2, so therefore its influence is squared. So we save the weight on the rim, and we produce that in carbon, and then the center section is made with a forged billet aluminium, which is then machined. In this case, this is the original wheel we designed in 2014 on a 3-axis machine, and then it's basically held together with titanium bolts and a patented system that connect the two parts together. That was our option wheel. We've now moved that story forward with the help of generative design, and essentially applying the same load cases. So what we basically do is we set up our constraints, firstly our load constraints, so we apply the same loads which we did when we designed the original wheel, but then we start to set up what we call our geometrical constraints. And principally it's around the package that we want to design the wheel around. So for us, obviously the caliper, the brake, how the wheel attaches, which fundamentally has remained unchanged from the original wheel. But from a pure aesthetic perspective, what we wanted to try and achieve was something which was really in harmony with the rest of the car's design and its aesthetic, i.e. this thinness. And so using the geometrical constraints within the software, it allowed us to maintain this 5-spoke design from the original 5-spoke. But basically we restrained these particular surfaces, and we restrained the 5-spoke design fundamentally. So it's an evolutionary design. And what that did is it made the algorithm and the software focus on saving weight around the center section, and particularly in the side. So you'll see now that the wheel has a thinness to it here, which is all part of this athletic, nature-inspired feel that the rest of the car has. So the wheel is very much now in harmony with the new design, and it's incredible to see that there's some significant pocketing that's happened in various different areas. This wheel has actually been produced on a 5-axis machine, so the algorithm's constantly looking at where it can save weight, where it can take weight out, where it can then apply the FEA analysis, but it's also self-checking how it's actually going to machine it as well. So this is machined on a 5-axis machine, and incredibly we've saved 1.25 kilos on that wheel, and that is a noticeable difference when you drive the car. Why? Because there's a gyroscopic effect with the rotation of the wheel that creates a vectoral force along the axis of the front axle. So when you're driving the car, you can actually feel the difference. There's an increased response in terms of turning, change of direction. It just completely transforms the car, and ultimately it's a 5-kilo weight save on the entire car. But vitally, it also helps to further enhance that driving experience. But it doesn't stop there, because for us the journey is what does the future look like? What does the next 3 years, 4 years, 5 years look like in terms of our journey. So we've basically gone from the original wheel to this, let's say, optimized wheel, which still bears a very close resemblance to the original wheel, but as I said previously, we've saved a significant amount of weight. But this is how far we can actually go. These are a 3D printed prototype parts, just for us to have discussions about how far we can take generative design. But it's just incredible. It starts to develop a completely different aesthetic from what we know today. And of course, the design challenge for the design team is at what point do we introduce that aesthetic, and what does the rest of the car look like to make sure that the wheel is in harmony with what ultimately you'd see through it and behind it, and actually the rest of the car. So for us, the journey with generative design is actually just starting. The wheel is just the start. We plan to do a whole bunch more work around the car in terms of system optimization. And it's going to be really interesting to see the weight saves that we're going to achieve with the further work that we're going to do, and obviously how that will affect the aesthetic, but equally important, the driving experience. So thanks to Autodesk for this opportunity for us to present our story and share our journey with you. It's been a great experience for us. We hope you've enjoyed it. Please stay tuned to the rest of our story via our social media platforms at Discover Mono, on our website bac-mono.com, and enjoy the rest of your time at the Advanced Manufacturing Summit.